performance trend charts, and comparisons. After any changes are made in a database, whether it's application, DB2 fixpacks, upgrading to new releases, it's important to check the performance consequences of those changes. I've noticed here that I have a SQL statement select flagged with a checkered flag. That means I thought that I fixed it. So right now we're going to take a look at a performance trend chart for that statement. I'm going to get a graph of response time and CPU time, and I'm going to dial the history way back to July 1st of last year. So this is quite a significant trend chart, and I'll extend that out to the 15th. Here we go. These performance trend charts tell a very important story. Here we can see the response time of the statement is 2 to 3.8 seconds, kind of in this range. And then we see a red diamond here. That's a memory change. After that memory change, look at what happens to response time. It tumbles all the way down to 1/4 of a second. Now that statement is running much faster. And then all of a sudden here, we see the response time of that statement shoot back up to almost 3 seconds. And look at right here. There's another memory change. Then we have a blue triangle where a physical design change was detected. And we've got response time here that drops off and becomes very fast. We're so fast we can barely measure it. There's half a second. Very fast here. A little burp there. And then over here we're back to running very slow again at 5 seconds response time, and we have another blue triangle. Well, what's happened here? Well, at this point in time, when the response time became very fast, what we can learn is that the buffer pool was changed. It was made significantly larger. What we did is we hid our performance problems in memory. We made the buffer pool large enough so that the entire table would fit in memory, and then we can see what happens when we hide our performance problems in memory. Things run fast until the memory is no longer big enough or CPU saturation occurs. At this point in time, buffer pool was changed again, and it was made significantly smaller from 6400 down to 500. At this point in time, where we have the blue triangle, we can see that an index was added. We've got an index that was created, it looks like on the 13th at 9:53 in the morning by DB2 admin, and that was on the columns hit timestamp, target file, and IP address. So there's a new index added, and after that new index is added, the statement runs fast. So the trend charts can tell very interesting stories for verification of how things are performing. Let's change the chart settings. Let's look at the average rows read for the same time period. There we can see very vividly what happens. We've got very high rows read here, and even though we made the memory much larger, that doesn't impact rows read. Now the rows are just being read in memory in the buffer pool. It's not until we create the index that the average number of rows read drops down to, well, practically zero, near zero. And then when the index is dropped, we see again that the average rows read becomes high again. Let's look at some database comparisons. To get the database comparisons, we begin at the database score and we click the workload compare button. On this comparison, I've already put in comparing early September of last year to late September of last year. What happened? Well, the response times dropped from 9 seconds to about 746 milliseconds, which is an 8.5 second improvement. CPU busy dropped from 31% to 24%. That's a nice savings. And look at here, our SLA attainment improved from 98 to 99%. Well, what changed? With just one mouse click, we can get a report and we'll find out what changed. Here I can see the buffer pool was increased from 2048 to 6400. That's the point in time when we increased the buffer pool and made the buffer pool very large. What happened to the statements when we made the buffer pool very big? Well, all I have to do is right-click here and choose Statement Compare. When I do that, I see this window. And on the Statement Compare, we can see all the statements that have improved here. This is the before time, the after time, and the improvement, 3¼ seconds on that one. Now, because what we did during this time frame, we made the buffer pool bigger to hide our performance problems in memory. And so you see here that all the index read efficiencies, they haven't changed. They're still terrible. We're just doing the scans in memory now instead of suffering to do I/O. And so here we have lots of statements that have improved. We kind of expected that because we're caching up our table in memory. And then we've got a few statements here that actually slowed down. So we can see for between any two time frames which statements have improved and which statements have degraded. The worst degradation was right here at 0.4 seconds. Now this is also interesting. You'll notice there's no comparison operator here. There's a before time, but the value for after time is 0. That means that this statement ran in early September but did not run in late September. And then we have a number here of statements where the before time is 0, and then we have non-zero values in the after time. That means that these are all new statements. So it's very easy for us to find out which statements are new. You know what's interesting, a little thing about our trend charts? If you look at drilling in on any time window, we can see what's running at that point in time. So at that point in time, which is shown here, we can see all of the statements that were running during that time and their performance attributes. Thanks for watching. That's comparisons and performance trend charts.